On this slide, what we're going to be talking about is we're going to be talking about a solenoid. Now, we just got done discussing this where we have a wire connected to a battery, and the wire is going to be shaped in a loop, and I discussed the direction of the magnetic field. What a solenoid is going to be one in which we have many, many, many of these loops. Not just one, but we're going to have several, and several of these loops, where N over here is going to be a fairly large number. And some uses of a solenoid is it acts as an electromagnet which is actuated to engage the starter in your automobile to help start your car. When a solenoid receives a current, it creates a magnetic field. It can control locks, it can control water pressure, it can control air pressure, it can act as a clamp. So solenoids have a tremendous amount of uses in our technologically advanced society. What we're going to do next is we're going to look at this solenoid as if we were to take a cross-sectional area of this. Now what we're going to look at is the cross-section of a solenoid. A solenoid is going to be long compared to its diameter. The magnetic field is going to appear as it does in this drawing here. So let me describe this drawing a little bit. Each one of these circles is going to represent a wire. All right? The plus here represents that the current is going away from you into the board. The dot represents that the current is coming out towards you. The pink here is going to represent the magnetic field. It's going to represent the magnetic field. Now, how do you determine the direction of the magnetic field? We're going to be using the right hand again, but we're going to use another right hand rule. All right, there are a few of these. Your book talks about right hand rule 1, right hand rule 2. In this case, we're going to be using right hand rule 2, in which our fingers are going to act in the direction of the current, and our thumb is going to be the direction of the magnetic field. And so in this case, the current is going away from you, and down here is coming towards you. So you're going to take your fingers and you're going to wrap it this way, and now your thumb is going to point in the direction of the magnetic field. And the direction of that magnetic field is going to be represented by our thumb, so it's going to go in our case from right to left, and therefore this is going to be the North Pole and this is going to be the South Pole. Now what about the strength of this magnetic field? Well, the strength of the magnetic field is going to be equal to mu naught I n, where mu is going to be the permeability of free space, I is going to be the current, and n is going to be the number of turns. N is going to be the number of turns. All right, so once again, the strength of this magnetic field is going to be mu naught I n, and our fingers are going to represent the direction of the current, and our thumb in this case is going to be the direction of the magnetic field. If you have any questions on this, please let me know.